Let's talk a little bit about exponential functions. Before we can do that, let's talk a little bit about laws of exponents. You probably remember these from high school. If you have two numbers raised to powers that we're multiplying together, and they have the same base, here a is the base, you add the powers. You keep the base and you add the powers. If you have a to the n and you raise that to the m, you multiply the powers. If you have a times b raised to the n power, both a and b are raised to the n power. If we have 1 and raised it to an n power, then we still have 1. If we have a and raise it to the 0 power, we have 1. And a to the negative n power is the reciprocal of a to the n power. That negative brings us down into the denominator. And of course, if we put a negative power in the denominator, we can bring it back to the numerator. So we're going to use those rules, and we're going to look at exponential functions. F of x equals c times a to the x power. Notice here our variable x is in the exponent, hence the name exponential functions. Previously we looked at polynomial functions where we had x as the base and a constant as the power, and that made a power function. So here we have x in the power. C is sometimes called the initial value of the function. That is, when x is 0, a to the x is 1. So we're left with just c. And a is called the base or the growth factor. Exponential functions is why we're talking about this online instead of in class. So what we look at to identify an exponential function from a table, for example, is a common ratio or a common growth factor. So if I have something like this, what I notice is the change between these two is 2 and then 4 and then 6. So we know it's not a linear function because the rate of change or the slope is not constant. But what we can say is if we take the ratio of these two, we are doubling, doubling, doubling. And so it has a growth factor of 2 here. So this function, f of x, is equal to, the initial value is 2 times 2 to the x power. Let's see if this works. If x is 0, we have 2 times 1 is 2. If x is 1, we have 2 times 2 is 4. If x is 2, we have 2 times 2 squared, or 2 times 4 is 8, and so on. So that is the exponential function for the table that I've listed. So you may be asking yourself, that's great, we have exponential functions. What are we going to do with them? One of the first things that we need to talk about and we need to do with them is we need to graph them. So I'm going to graph 2 to the x. So my initial value here is 1. We'll make a quick xy table or xf of x table. And let's put 0, 1, 2, 3 over here. -1, -2, -3 over there. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. Now, what about 2 to the -1 power? What did we say? That was one of our properties. That negative brings us down to the denominator. So this is 1 over 2. Okay, what about 2 to the -2? That's 1 over 2 squared is 1 over 4. And then 1 over 2 cubed is 1 over 8. So our graph looks like the following. We have an intercept at 0, 1. We've got a point at 1, 2, and then 2, 4, and then 3, 8. To the left, there's a half, there's a quarter, there's an eighth. So it's really flat over here, and then it starts growing, 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 growing. So there's our exponential function 2 to the x. Some points you want to notice, some features you want to notice. You've got a y-intercept right there. We've got a horizontal asymptote on the end behavior this way. You have y equals 0 horizontal asymptote. And then to the right, as x gets bigger, y also gets bigger.